Okay everyone, so now we are learning JVM, JRE and JDK in Java. First of all, we are starting with the JVM. JVM stands for Java Virtual Machine. To understand the JVM, I'm taking the example here. Let us suppose that we are making a code in Java. So let's say this file we have created, inside that we have provided the Java code and the name of file is, let's say, ankit.java. The program written in Java is called source code. Now afterward we are having is the Java compiler, which is Java C. It is converting the source code or Java file into the bytecode. This is the class file. This file nobody can read. So that is the bytecode, which is very secure. So we can send it to anybody. And this is the, let's say, ankit.class. This class file is called bytecode. So here in the first phase, we have converted the source code to the bytecode. This is called the compilation phase. After the first step, bytecode is created, which is very secure and which can be sent to anyone, means from one system to another, and nobody can read in between. That's why Java is very secure. On the second phase, the bytecode is converted to the native or machine code. Now here, the bytecode can be converted that it can work on Windows, or it can work on Mac, or it can work on Linux. So or any OS, Java can work. That's why Java is platform independent. Here we are having is the JVM. We can see that there are 3 JVM which are shown. That means the first JVM, that is for the Windows, second one is for the Mac, and third one is for the Linux. That means JVM is the operating system specific. So here JVM is acting like an interpreter and it is converting the bytecode to the native machine code line by line. That's why this second phase is called the interpreter phase. So here in Java we are having 2 phases. One is the compilation and second one is the interpreter. So here Java is called compiled and interpreted language. So here we have learned that JVM is going to convert the bytecode to the native machine code. So here we are using the JVM, which is Java Virtual Machine. This JVM provides the runtime environment in which Java bytecode can be executed. In the JVM we have word which is virtual. That means it don't exist physically. So the Java Virtual Machine don't exist physically. JVM is a abstract machine, which is not a real machine, which don't exist physically, but yes, it acts like a machine. So that's why it is called, it is a abstract machine. Here we can see that in the diagram, Windows has its own JVM, Mac has its own JVM, Linux has its own JVM. That means JVM is operating system dependent. Windows has its own JVM. The meaning is that Windows has its own specification. Based upon that, it wants a native code in its own requirement. That's why the JVM is required for the Windows. Similarly, Mac has its own specification. Based on that, it has the JVM. So here, bytecode which we have, that can be converted to any of the operating system according to their JVM. So here, JVM is operating system dependent. But because we are having the bytecode, the Java is platform independent. So here we are converting the source code to the bytecode. Then bytecode can run on any of the operating system based upon their JVM. That's why Java is platform independent language. There is an important point that when to use JVM. If you want to make a application in Java, means develop the application, JVM cannot be used. But let's say if you want to run the application in Java, then for that purpose, JVM is used. So JVM can only run Java application line by line. Line by line means it is the interpreter. So JVM is the interpreter who run line by line and it only run the Java application. Development is not there. So we can say that if in our system we are having the JVM, that means we can just run the Java application line by line. We cannot develop the Java application. So JVM is not for Java application development. So here we have learned that JVM is a virtual machine. It is an abstract machine which physically don't exist, and it provides the runtime environment. Here it performs the task just like loading the code, verifying the code, execute the code. And here bytecode can be executed. Here we are only running the Java application. We are not developing the application. JVM run application line by line. That's why it is called the interpreter also. That's why in the Java we have interpreted phase also. So Java is compiled and interpreted. Now we are learning the JRE, which is Java Runtime Environment. JRE is also called Java RTE. So here RTE signify runtime environment. So this is Java Runtime Environment. We know that inside the Java we use JVM. JVM use certain set of libraries. So here JRE, which is Java Runtime Environment, it contains set of libraries and other files that JVM use for runtime. So JRE provides set of library, just like we are having the archive files, which are .jar. So these jar files, jar means J for Java, AR for archive. So Java archive files and some other files, they are provided by the JRE so that JVM can work on runtime. So combinedly this thing is called JRE, means Java Runtime Environment. So here JRE, which is Java Runtime Environment, it provides set of library, which are the jar files and some other files that help the JVM to work on runtime. So here JRE provides the runtime environment. We know that JVM is a virtual machine which don't exist physically, but here JRE exists physically. We know that JVM is a Java virtual machine which is not physically available, and it helps the Java code to run. But here, to work JVM, we need some set of library and other files which are provided by the JRE. So actually, runtime environment is provided by the JRE. So here we can say that JRE is the implementation of JVM. So behind the working of JVM, there is JRE, because JRE provide all the library just like .jar files and other files to the JVM so that JVM can work. As we know that JRE is the implementation of JVM and it is also providing the runtime environment. So here JRE is only used for running the application. It is not used for developing the application. So here we have learned that JRE is the Java Runtime Environment. This is also named as Java RTE, that means Runtime Environment. If we see the similarity between JVM and JRE, then they both can only run the application. They both cannot develop the application. They both provide runtime environment. But there are certain difference between JVM and JRE. JVM physically not exist, but JRE physically exist. Now, JVM is used to run the code, but here it is not having the physical presence. That's why to make it real, to work, we are having the JRE. That's why it is called implementation of JVM. Because here in JRE, it provides set of library, just like archive file, .jar files and other files. With the help of that, JVM can work. So here it is the real implementation of JVM. So JRE contains the set of library and other files so that JVM can work at runtime. But they are used for only running the code. They are not to develop the code. So now we are learning the JDK. If we want to develop an application in Java, then we need the JDK. So let us suppose that you want to make an application, you want to design a code in that case, JDK means Java Development Kit is required. So it is software development environment. So in JDK, which is Java Development Kit, we are having the development tools, just like we are having the Java compiler and the Java. So these development tools are available. With the help of that, we can develop an application in Java. So here JDK is the combination of JRE as well as development tools. So JDK, which is Java Development Kit, that contain JRE, which is Java Runtime Environment, and the development tools. JDK also physically exists. JDK is used for both things. We can run the application as well as we can develop the application. So JDK is used to develop and run Java application. So if we see the difference between JVM, JRE and JDK, then here JVM physically not exist, but JRE physically exist and JDK physically exist. In JVM, we can run the application. Similarly, in JRE, we can run the application. Similarly, in JDK, we can run the application. But if we talk about developing, in JVM, we cannot develop the application. In the JRE, we cannot develop the application. But here in JDK, we can develop the application. JVM is used for running the Java application. Here JRE provides set of library and other files so that JVM can work. That means JRE is the implementation of JVM. And here in JDK, it also provides the development tools just like Java, Javac, and it contains the JRE also. So here in JDK, we can develop the application as well as we can run the application. So that is all about the JVM, JRE and JDK.